Hello students, in the last class we have studied about chemical reactions, and in this class we will be moving further with the chapter with the topic chemical equations. Chemical equations, these are required to represent a chemical reactions, and it can be represented in the form of word equation and in the form of symbol equation. So when we are talking about the word equation, here it is represented in the form of words. So magnesium plus oxygen, we are representing it with the whole total word form magnesium plus oxygen, and to give the product magnesium oxide. In the symbol form, we are writing the symbols of that elements. Magnesium plus oxygen, it gives magnesium oxides. And here, to represent any reaction in the notebook, this becomes more convenient because it is in the shorthand form. Now, when we are talking about this, where should we represent the reactants? It should be represented in the left hand side, and the product should be represented in the right hand side. So here we can write that this is represented in the left hand side, and here it can be represented in the right hand side. Now, when we are talking about this reactants and the products, the atoms present in the reactants should be equal to the atoms present in the product. But here we are not finding that. We are finding what? Here two atoms of oxygen are present, but only one atom of oxygen is present over here. So this is not following the law of conservation of mass, or you can say that matter is neither created nor destroyed. So this type of equation is known as skeletal This type of reaction is called what? Skeletal equation. And in order to follow the law of conservation of mass, we need to balance the equation. So now we are continuing with the topic balanced chemical equation. Why do we balance a chemical equation? As already explained, we need to obey the law of conservation of mass. Means what? Matter can neither be created nor be destroyed. Because if any atom is less or if it is more, how does it can happen? Because matter can neither be created nor be destroyed. This can't happen. So we need to balance a chemical equation in order to obey the law of conservation of mass. Now, if we are seeing this reaction, is this reaction balanced? Zinc plus sulfuric acid, it is giving zinc sulfate plus hydrogen. Now, we have to divide this reaction into two parts, left hand side and right hand side. Left hand side represents the reactants, that is zinc plus sulfuric acid. Right hand side is representing the product, that is zinc sulfate and hydrogen. So now next step which we will be following is we will be making a chart in order to see whether the elements over here are equal or not in the reactant and the products. Now the next step is we'll make a chart and we will count the atoms in the left hand side and in the right hand side. So the elements present in this reaction are, first we'll write that zinc, then we can see what? Hydrogen, and we can see what? Sulfur, and then oxygen. Now let us count the atoms in the left hand side and right hand side of the reaction. How many zinc atoms are present? So left hand side 1 zinc, right hand side 1. So you left hand side you are getting 1, right hand side also 1. Now come to hydrogen. In the left hand side it is 2, in the right hand side it is 2. Now come to sulfur. In the left hand side it is 1, in the right hand side it is 1. Now come to oxygen. It is 4 in the left hand side, in the right hand side also it is 4. Now see the chart. Here for zinc, if you are seeing, the number of atoms in the left hand side and the right hand side is equal. In case of hydrogen also it is equal, in sulfur also it is equal, and in case of oxygen also it is equal. So what can we say about this equation? This is a balanced chemical equation. What do you say? This is a balanced chemical equation. Now take the example of magnesium reacting with oxygen to form magnesium oxide. So first step, divide it into left hand side and right hand side, the reaction. So you are getting here what it is, magnesium plus oxygen. RHS, you are getting what? Magnesium oxide. Next step, make the table. Element, number of atoms in LHS, number of atoms in RHS. So now let us start. Here in the left hand side, the elements in the left hand side and right hand side first we have to write. So here the elements which are present is magnesium and oxygen. Now let us count the atoms. Magnesium in the left hand side we have 1, in the right hand side also we have 1. Here you can see of oxygen in the left hand side it is 2 and right hand side it is 1. So what we need to do is we have to multiply it with 2. And it becomes now oxygen became what? 2. So if oxygen became 2, so now if we try to write the reaction, magnesium plus O2 gives MgO. Now here right hand side also oxygen is 2, so we will be writing 2 over here. This is only a partially balanced reaction. Because, why? Here magnesium is 2 but magnesium over here is only 1. So if here it has become 2, so you have to multiply over here also with 2. So now here it is 2. But in the left hand side it is only 1. So here also you will multiply it with 2. So it now became what? 2. Here also 2. So now it became what? 2 Mg plus O2 gives 2 MgO. Now count the atoms. In the left hand side 2, right hand side 2, left hand side 2, right hand side 2. Here also you can see 2 magnesium, oxygen 2, oxygen 2. So this is a balanced chemical reaction. And it has been totally got balanced over here as the number of atoms of the elements over here is equal to the number in the right hand side. Now let us take another example. Fe plus H2O gives Fe3O4 plus H2. In this reaction, first of all, as you get it, don't change or write anything over here. Let it be as it is. Next step, what you will do, if you find any convenience, if you find that yes, if we make boxes then it will be okay, then you can write in this manner Fe, make it in a box, plus H2O, another box, and you are getting Fe3O4, this also, just specify it, plus H2 if required. Next, you can write the reaction of the left hand side and the right hand side. Left hand side, it is iron plus H2O. Right hand side, you are getting Fe3O4 plus H2. Next step is we are going to again make the chart. That is, you will write the element first, then number of atoms in LHS, number of atoms in RHS. So now we have made the box and start writing the elements. First is iron, hydrogen, oxygen. So iron, when you are seeing how much it is in the left hand side, only 1. Right hand side you are having 3. Come to hydrogen, in the left hand side you are having 2. Right hand side also 2. Oxygen in the LHS side is 1 and in the RHS side is 4. Now see, here iron and oxygen, there is difference in the atoms, but in hydrogen it is okay. So what we should take, iron or oxygen, there is a question. So the next step is that we should take the atom which is present in the maximum number. So when we are seeing that here oxygen is 4 and it is in the maximum form. So first we will be taking what oxygen in order to balance the reaction. Now you can see the difference in the number of atoms in the left hand side and in the right hand side of these different elements. So now what to do, which should be balanced first. So we have to see that which element is present in the maximum number, we have to balance it first. So here we are seeing oxygen which is 4 in number and this is the maximum number of atom. So we will be starting with oxygen. So in order to make oxygen 4 in left hand side also, what we will be doing, we will be multiplying it with 4. Now let us try to write the reaction. What it becomes, Fe plus H2O. Here we have added 4, so we'll write 4 and we are getting Fe3O4 plus H2. So now when we have added 4 over here to this oxygen in the left hand side, we can see there is a difference in the number of hydrogen here. So what we have to do is here this 4, it should be multiplied over here. So now it becomes what? 8. As soon as it becomes 8, the number of atoms in the right hand side becomes disturbed. So in order to balance this hydrogen now, what we are going to do, we will be adding and multiplying it with 4 and we are getting 8. So now we are seeing hydrogen is balanced, oxygen is balanced, but here iron is not balanced. So last we are taking iron, and iron here it is right hand side 3 and in the left hand side it should also be 3. So we will be multiplying it with 3 and now you can see the number of atoms present in the left hand side and in the right hand side is equal or not. 3 atoms of iron are present over here, 3 atoms of iron present, okay, 8 atoms of hydrogen, and here also 8 atoms of hydrogen is present over here. And now you can see oxygen is 4, here also oxygen is 4. So now we can see, yes, this equation has been balanced in the left hand side also and in the right hand side also, and so now this reaction is balanced chemical equation. For balancing of chemical equations today we have used, the method which we have used is the hit and trial method. And this is all for today. In the next class we will be studying about types of reactions. Take care.